So today we are looking at a situation, a question that combines length of arc and theorems in circle geometry. We all know length of arc is when a radius is formed between 2 points on the circumference of a circle. If I have this circle from the center, let me call here point AB. So the whole of this point from A to B represents the length of the arc, and from the center O to the circumference B and circumference A is radius. So this is the concept of length of arc, and the expression for length of arc is theta over 360 times 2 pi radius. This formula for length of arc. So let's keep this in mind, that we have length of arc as this. Let's keep this man in mind, this formula for length of arc. Like I said earlier, it's a combination of length of arc and some theorems in circle geometry. So what we're going to do for here now is to redraw this diagram and put some missing details inside the diagram. We are told that in the given figure, AOC is a diameter. And what is a diameter? A diameter is a straight line that passes through the center of a circle and touches 2 points on the circumference of the circle. So what does it actually mean in essence? If you are told that a line is diameter, let me make a sketch. Let's make a sketch of a line that will illustrate a diameter. So it is a circle, and I have a line that goes through the center of the circle. That line is a diameter. So I can say AB is a diameter. But what's the actual implication when you come to circle geometry? If I should form a point as C, let's call this point C. What it actually means is that the opposite side must be 90 degrees. The opposite side must be 90 degrees because the center is simply 180. This center is 180 degrees. So if you apply the theorem of circle geometry that says angle at center is twice the angle at circumference, you will see that angle C will give us a 90. So, and from A to B represent the diameter. And we know from measuration, diameter is 2 radius. So radius is diameter over 2. That's the expression for radius. So that means from O to B is radius, and from A to O is radius. 2 radius will give us a diameter. So with this in mind, let's see how we can tackle this question. So I need to redraw the diagram and put the missing data that are not imputed in the question. Let's see how it goes. So I have let me redraw the diagram. Now this is the diagram. We have a line here, a point here, a point here, and a point here. And we are told here is center O. Then here is ACB. Here is point A, C, and B. So we are told that line AC is our diameter. Line AC is diameter. So from my previous explanation, it simply means that from O to C is radius, from O to A is radius. So a radius is a fixed point from the center of the circle to any point on the circumference. That means from O to B is also radius. And we are told that the arc AB is x, and the arc BC is y from the question. So they also made a statement that the arc A arcs B is half the arc BYC. We're asked to find angle BOC. So let's see how we achieve that. So the arc, length of arc, let's say length of arc of AB is half the length of arc of BC. That's what we are told from the question. And the length of arc from BC is x, is equals to 1 over 2. The length of arc of BC is y. AB is x and BC is y. So let's keep that in mind. Then don't forget, we are told that line AC is a diameter. That means the whole of this angle here, the whole of this angle at B is 90 degrees. That's what it means, since line AC is a diameter. So let's classify this angle OBC as theta. Let's call the whole of this angle as theta. Now, since we know that OB and equals to OC, it simply means it is what? An isosceles triangle. It simply means an isosceles triangle. That means angle OBC, same thing as angle OCB, meaning here is also theta. As you know, from plane geometry, sum of two interior angles equals to an exterior angle. That means if I sum these two theta, will give me this angle here. So mean here is 2 theta. Because AOB is an exterior angle compared to BOC. We also know that since OB and OA are the same, both of them is also, this triangle is also an isosceles triangle. So since we have here as 2 theta and here is theta, we can now apply the concept of length of arc by quoting the formula of length of arc. So let's consider the length of arc of AB first, and let's consider the length of arc of BC. Then we equate them to this expression because it says the length of arc of AB is half the length of arc of BC. So let's get the length of arc of AB with the angle 2 theta. Then what is now the angle for the length of arc of BC? Which is this angle here, which is angle O. So angle O, without being 2, will give us 180 minus 2 theta. Because AOC is a straight line. So the two angles are supplementary, meaning the sum of both will give us 180 degrees. So the that of AB is 2 theta, that of BC is 180 minus 2 theta. So let's get the length of arc of AB. So I will code my expression. Length of arc is theta over 360 times 2 pi radius. So the length of arc now, which is x, is now 2 theta. Our theta is 2, 360 times 2 pi radius. Let's call this equation 1. Then the length of arc of BC is y, and the theta there is 180 minus 2 theta. So length of arc of BC, which is y, is equals to 180 minus 2 theta over 360 times 2 pi radius. So let's call this equation 2. So we are told, let's go back, let's look at our expression. We are told from this expression here that x is 1 over 2 y. So if I make y the subject formula, what are we having? My y will simply give me what? 2x. That means I will simply cross multiply. My y will give me 2x. So anywhere I see y, I will put the length of arc for y. Anywhere I see x, I will put the length of arc for x. So let's do that and see. So I'm going to have length of arc for y is this expression, which is 180 minus 2 theta over 360 times 2 pi radius is equals to 2 times, because we said is 2x. So that is 2 times the length of arc of x, which is 2 theta over 360 times 2 pi radius. So if you look at this expression we have, we can cancel out those that are cancelable. 2 pi arrow can cancel 2 pi arrow. You also agree with me, 360 will cancel 360. So what do we have left? We're having 180 minus 2 theta is equals to 4 theta. because 2 times 2 theta will give us 4 theta. To find theta, I will simply collect like terms by inviting 2 theta to meet 4 theta. So if that should happen, we're going to have 4 theta plus 2 theta equals to 180. So I'm having 6 theta is equals to 180. Therefore, my theta is now 180 divided by 60. Theta will give us 30 degrees. But we're not looking for theta. The question specifically asks us to find angle BOC. So let's trace the angle from the figure we drew. Angle BOC. BOC, which is the value here. What is the angle there? 180 minus 2 theta. That is the value of angle BOC. So let's fix that. Angle BOC is simply 180 minus 2 theta. This is what we have as angle BOC. What is our theta now? It's 30. Let's fix it. We're going to have 180 minus 2 bracket 30. So angle BOC will give us 180 minus 60. 180 minus 60. So we're close to the final answer. Please don't forget to subscribe, drop a like, and also comment on the video. Thank you very much. So what is the value of theta of BOC now? It's simply 120 degrees. So to me, this is a very exciting question. If you want to see more other questions, always check on our channel, STEMupAfrica. Thank you. Hope to see you in our next video.